Welcome to the Unit 7 Take-Home Test video key. Okay, just a quick reminder, anything that's in blue is something that I've already done for you. You can use that work and those answers to check your own work. Anything that's highlighted in yellow is something that we are going to do together in the video. And anything that you see highlighted in pink is something that I'm going to leave for you to do. Alright, there's extra credit hidden in here, so make sure you are finding it. First things first, go ahead and check these vocab words. I've gone ahead and written memorized here in the margin because this is just essential vocabulary from last unit, Unit 6, for this unit, and for next unit, Unit 8, that we need to be good with that. Okay, so let's take a look here. Number 2, I highlighted some keywords here. The formula is the exact number. That means reduced. So which is the reduced formula? That would be the empirical formula. That's our simplified. Okay. The unit that we measure mass in would be the gram, E. This number is a mole. That's Avogadro's number. We don't want to say the mole for this one. We want to call it Avogadro's number. The formula that indicates the simplest. You know what? I totally am having a hard morning, apparently. I said this backwards. The formula that is the simplest whole number ratio, so the simplified or reduced one, that is going to be our empirical formula, The exact number, that would be unreduced. So that would be like dihydrogen dioxide, H2O2, it's the exact number. That's going to be our molecular formula, D for number 2. Excuse me on that one. The mass of 1 mole, that has units of grams per mole, would be the molar mass. Okay. Make sure we know our units. The mass of a mole, we've got mole and mass in it, and we've got moles in the unit. And the unit that we count amounts in would be C, the mole. Okay, so if you work at a bakery, you count your amounts by the dozen. If you work in a chemistry lab, you count the amounts by the mole. Alrighty. Down here for these ones, this is just fair warning, you are getting 0 credit, not partial credit, 0 credit without showing dimensional analysis work, because the name of the unit is dimensional analysis. Okay, that's kind of our point here. I am going to go ahead and do this and offer y'all 2 points extra credit if you write this in the margin here. So box in your given and circle your unknown. This is something that at least home students are required to do. It is going to be super helpful for the rest of this year as we're doing some more math. Okay, so I've already gone through and boxed and circled my given 5.5 kilometers. How many meters is that? So I'm always going to start all the way to the left because I don't know how many steps this dimensional analysis is going to be. And you are going to need a copy of the 3rd grade star chart. So if you don't have one with you, you can go to your teacher's Canvas page under the Unit 7 materials. We've got this. Okay. But I'm always going to start by whatever I box in goes in the first box. So 5.5 km per kilometers. And then we just go down to our units, which means whatever unit I have up on top, I need to cancel out by bringing down below like that. So I'm going to put kilometers here. And then we can come over here and figure out what we know about kilometers. So I know 1 kilometer equals 1,000 meters, and that's it. That's the only thing that it says about kilometers on here. So my only option is to put meters on top, which, look, that's what I'm actually looking for. So I have what I boxed in the top left, what I circled in the top right, which means I'm done. I don't have to do another step with this one. And then we can go ahead and fill in our units so that the top equals the bottom. And it says 1,000 meters equals 1 kilometer. So 1,000 meters equals 1 kilometer. Top times the top divided by the bottom. Go ahead and put your answer here and make sure you include units. Okay, I'm just going to help you set this one up as well. I already boxed and circled. So 3.20 gallons, G-A-L. And then I'm going to disco that unit down here. And now that I've done that, I can try to figure out what I know so I can make an equal sign right there. So for gallons, I know 1 gallon equals 4 quarts. And also right here, that 1 gallon equals 3.79 liters. So because I'm looking for liters, that's what I want to put on top. And that's my final unit. That's what I circled, so I'm done. I don't have to keep going and do more than one step. So then we say, according to this, 1 goes in front of gallon and 3.79 goes in front of liter. this times this divided by the bottom. 1 is not always on bottom, but in this case, 1 went in front of gallon, and that happens to be on the bottom. So solve that and make sure you're putting liters as your answer unit. Excuse me. All right, let's do all of number 10 together. So again, I boxed in my given and circled my unknown. Please don't think that you are saving time by not doing this. It's going to catch up to you, especially in Unit 8 if you are not making this a habit. So actually box and circle, please. And remember, for dimensional analysis, units are our best friends. I've got this, which I maybe should show you. Units are your best friend. We always put our given in the first box, and then we keep discoing until we have our unknown in the top right-hand corner. Okay, so make sure we're checking for that. All right, 72.3 inches. And I'm actually going to write that unit because it's my best friend. So I know to disco down inches. And I'm going to look at, can I put yards right on top, what I want on top. So for length, what do I know about inches? I know 12 inches equals 1 foot. That doesn't get me, well, there's yards. I also know 1 inch equals centimeters, but centimeters gets me on this side, and I don't want to go there. So what I want to do is do inch equals yards, but I don't have that number on here. So I can go inches to feet, and then feet to yards. Okay. So I'm going to put feet on top here. And that's not my final answer, so I have to do another step and disco this unit down, feet. Okay, and I do know that feet equal yards. I know that conversion. So there is what I circled, so now I'm done. I don't need to do another step. And now that I've done all of my units, oh, my friends, then we can come back and get the number. So 1 goes in front of foot, 12 goes in front of inches, because 1 foot equals 12 inches. For yards, 1 yard equals 3 feet, so I'm going to put 1 in front of yards and 3 in front of feet. And then I'm going to multiply all the way across the top, and I'm going to switch colors for us. 72.3 times 1 stays 72.3. And then on the bottom, I'm going to multiply across. So 12 times 3 equals 36. And then being very careful that you don't put this in your calculator backwards, I'm going to go the top divided by the bottom. Okay, so 72.3 divided by 36 equals 2.008. So I'm going to go ahead and just put 2.0. And what are my units? Okay, if inches is on top and bottom, it canceled out. Feet is on top and bottom. So the only unit I haven't crossed out yet would be yards. 2.0 yards of fabric. Alright. I set this one up for you, and I gave you the answer. So you can check your work. It should be 1, 2, 3 steps. If you don't finish this work, you're not going to get credit for it. But if you didn't get this answer, maybe you're having a problem with units. So go ahead and take a look at that. Okay. That's page 1. Let's go ahead and move on to page 2. For page 2, I've got that answer right there for number 12. Go ahead and check your work. Make sure you have shown your work. Alright. For number 13, I'm going to let you all do it, but one thing I want to caution you on is in class we usually write it like this, and then when students see this, they're like, ah! Remember, this is the same thing, okay? These little train tracks that we've been drawing on our homework is just shorthand for this, so that's the same thing. Don't let that freak you out. And then let's look at number 14 together, okay? For number 14, just because of how I like it, I'm going to go ahead on my actual copy, my take-home test, and my actual test. I'm going to add those dimensional analysis bars back in, the train tracks, because that's how I'm used to seeing it. And then I'm going to make sure that my given is in the first corner. So all of those match. That's good. And the next thing I should do is disco down my units, centimeters. This one disco down centimeters, this one brought down centimeters, and that one brought down centimeters, so that works. And then this one put kilometers right on top. So I'm going to look that up and say 1 centimeter does not equal kilometers. I can't put it directly there with my information. And certainly 1,000 centimeters does not equal 1 kilometer. So I'm going to take out the garbage on this multiple choice test and say, no, there's no way that one's right. Centimeters down to meters. Meters down to kilometers looks pretty good. Centimeters to meters, meters to kilometers, centimeters to meters. Ooh, look at this one. This person didn't disco down meters. Meters should be on bottom here, so this one's wrong too. So just by looking at the units, I was able to cancel out A and D. And then we can come back and check the numbers. 1 meter equals 100 centimeters. 1 meter, where does that say? Equals 100 centimeters. That's true. So this one looks good. 100 meters equals 1 centimeter. That's not true. They got those numbers backwards. So this one I know is wrong, which means now I can say, all right, that's the correct work for solving this problem. Okay, we're done with that star chart now. We're going to get into some more chemistry stuff. Looking down here, molar mass calculations. Okay, I gave you the answer so you can check it on this one. And then I'm going to let y'all go ahead and show the work, otherwise you don't get credit. But let's look at this one real quick. Calculate the molar mass of aluminum sulfite. First thing, you cannot find molar mass from a name. It doesn't work. You have to have a formula for it. So let's look at that. Aluminum is one of the 3 in the 3A exception block that always makes a +3 charge. So I'm going to do symbols and charges. Sulfite, not sulfide, so it's not sulfur. It would be sulfite, SO3 -2 right there. I apologize, sorry. SO3, making a -2 charge. Okay, so bring the 2 down and the 3 behind it. So there's my chemical formula. Al2, SO3, 3. Now, a question that's very similar to this was one of the most missed test questions on the Unit 8 exam, or excuse me, the Unit 6 exam that we just took, where it said calculate the molar mass of aluminum. I think it was sulfates instead of sulfites, but a lot of students were missing it. And I think the problem is then counting atoms. So, Al2 means 2 aluminums, so I've got 2 aluminums. SO3, 3 actually means SO3, SO3, SO3. So that's 1, 2, 3 sulfurs, okay, because we distribute that 3 inside. And then that's going to be 9 oxygen, because 3 times 3 is 9 oxygen. So I'm going to let y'all finish this one up now that we've counted the atoms. But you're going to take 2 aluminums plus 3 of the mass of sulfurs plus 9 of the mass of oxygens. That's how we find the molar mass of aluminum sulfites. Okay. Let's get into some conversions, and I'm offering some more extra credit on this page. Okay, in order to do any kind of conversions, we need our conversion factors. So on the back of your periodic table, you have these conversion factors where it says mole equals grams equals map for you. Okay, so I want you guys to go ahead and put +2 extra credit, and then fill this in. 1 goes in front of mole for our conversion factor. It's what my periodic table says. It equals in front of grams. I'm going to have you write molar mass. So that changes based on what my compound is. Equals, and this map for you is Mr. Rouse's idea, so it's map for you molecules, atoms, particles, or formula units. All of those things have that number in front of it, which would be Avogadro's number. 6.02 times 10 to the 23rd. So if you can get your units done, if you can just go down your units and put what you're looking for on top, that's always going to be your numbers. And those don't even have to get memorized. You just have to know where they are. Okay? So look in here. I gave you the answer on number 18. So you can check your work, but make sure you're showing your work. If you got it wrong and you don't know why, watch the rest of this page. Maybe you can come back and take a look at it. Okay? I'm boxing my given, 1,100 grams, and I'm circling my unknown. So let's take a look at this one. For me, I always do these chemistry ones as one-step dimensional analysis. And I'm going to put what I am given, whatever I boxed in, goes in that first box, which would be 1,100 grams. So I always start by dancing. I'm going to take my unit and bring it down here. And then I can put what I want it to be on top, which is what I circled, mole. Okay. And then we go to the periodic table, or we have it written right there. A mole gets a 1 in front of it, and gram gets the molar mass in front of it. So that's where we have to say, okay, molar mass of what? That would be of iron 3 oxide, which I wrote that formula, because iron making the 3 charge oxygen. I got that. So real quick, we're going to have to calculate out that molar mass. So 2 irons. Fe is right here in the middle, 55.845. So 2 times 55.845 equals, okay, now plus 3 oxygens. So 3 times 15.999. The molar mass of Fe2O3 is 159.687. So in this problem on number 19, I am not using Avogadro's number at all because I don't have map for you in there. I have moles and grams. So we're going to go ahead and put what we just calculated, 159.687 in our in front of grams. And then we can come back and say 1,100 times 1, which is redundant, right? We don't really need to do that. Then divided by the bottom. So divided by 159.687 equals 6.88. Okay, or 6.89. I have to have a unit in my answer. So grams canceled out, my unit would be moles. Okay. Looking down here, I gave you the answer for number 20, and I want you to show the work. I apologize, I'm going to have to put a cough drop in, guys. Tis the season. Okay. Looking at this one, I set this one up for you a little bit here, okay, where I put the given, and I just go down grams, and I put formula units, abbreviated unfortunately there as FUs, and then in front of formula units, in front of the map for you, I put Avogadro's number, and in front of grams, I'm going to have to put the molar mass. So I calculated that out for you. Potassium, oxygen, and hydrogen should be 56.105. That's the number that goes on bottom. When we calculate it, you can go ahead and check your work. All right, let's work number 22 together. Calculate the number of atoms. So that's what my answer is going to be, blank atoms, in 22.6 grams of copper. So I'm going to start by making my 1 T-bar, and then I'm going to put whatever I boxed in my first box. 22.6 grams of copper. Sorry. And then I just go down that unit, down to the bottom, grams of copper. And I'm looking for atoms, so that's what I put on top. I always do my units first, especially as we get into stoichiometry next unit. It's a lot more involved, there's a lot more steps, and the units will help us out a ton. So, I've been asking my students, where does the 1 go, on top or on bottom? And it's a trick question because the 1 only goes in front of mole. And if I don't have mole written here, I'm not using this number at all. I'm using these 2 numbers. So the molar mass goes in front of grams, which is on the bottom. And that would be the molar mass of copper, 63.546. And in front of atoms, map for you, up there, gets Avogadro's number in front of it. 6.02 times 10 to the 23rd. Okay, I'm going to show you real quick, if I can find it. I'm going to show you how to put this in on a different calculator. Dang. Sorry, guys. 22.6, so I'm going to go times the top. So 6.02, and then times 10 to the power of, we said was the EE button, the easy exponent button, which on our class calculators is right here. But on my calculator, it's this yellow EE, so I have to hit second easy exponent, 23, and that enters it the same way. So there's my top answer, and then I need to divide it by what I have on the bottom. So divided by 63.546 gives me an answer of 2.14 times 10 to the 23rd power. Okay. 2.14 times 10 to the 23rd atoms would be my unit. Okay. Go ahead and check your work on number 23. And we're going to look at 24 together as well, just because there's really lots. It's the same thing over and over again, but if we're going from molecules to mass, or molecules to moles, or grams to atoms, we're using different numbers in the places, but it's the same process. So again, whatever I boxed in right here goes in this top box, so 5.45 times 10 to the 22nd, and don't abbreviate molecules as moles, that's not the same thing. Molecules. Okay, I'm going to take that unit that I'm actually writing, it's not a shortcut to skip it, okay, and write molecules. and I'm looking for mass. So I don't want to write mass on top, I want to write mass as units, which on page 1 we said was grams. So I didn't write the word mole anywhere, so I'm not using the number 1 anywhere. In front of grams, remember it's on the back of our periodic table, or we put it up here. In front of grams was the molar mass, and the molar mass of neon right there, 20.180. That's what's going on top. And in front of molecules, that's one of the maps for use, gets Avogadro's number, 6.02 times 10 to the 23rd power. Okay. So let's, again, be real careful and intentional how we put this in our calculator. 5.45 times 10 to that, I'm going to use this easy exponent button right there, 22nd power, times what was on top, okay, 180 equals, and I divide that answer by the bottom. So divided by 6.02 easy exponent 23, because that is the same number in the calculator. And I get 1.82, or 1.83, or 1.8. Okay, so I'm going to go ahead and put 1.83 grams. That's my unit that's left. Okay, this is kind of the point of the unit. It's most of what's going to be on your test. Let's see if we can't get this. All right, more extra credit on this page for being resilient. It's our third one. Go ahead and write +2 EC, and then blank map for you. Just because that's what students seem to be forgetting, is that molecules, atoms, particles, map, and then etc. formula units all have Avogadro's number in front of it. So I'm going to go ahead and add that in here. 6.02 times 10 to the 23rd. That's what we use for that conversion. So I'm going to speed this one. 1.50 mole. I just go down that unit mole, and I put what I want on top, what I circled, which is formula units. Okay. I know a mole always gets a 1 in front of it, and I know that map for you gets Avogadro in front of it. So 1.5 moles, 1.5 times 6.02 easy exponent 23 equals, divided by 1, still is 9.03 E23. So 9.03 times 10 to the 23rd formula units, like that. Okay. Showing work on calculations, I found this formula for you in case you need to check your work. But remember, you cannot find molar mass from a name. You have to have the 4-step formula. All right. I've already go ahead and started this one. So it's a multiple choice question. We want to be real careful that we're still showing our work. So how many atoms, what I circled, are contained in this given 3.0 moles? So I wrote my given in the first box, and I just go down that unit, and I put what I was looking for on top. So a mole always gets something in front of it. Atom always gets something in front of it. Okay, look at the back of your periodic table and finish this one out. Okay. Same thing here. I started it for you. I put the given, and just go down the unit and put what we're looking for. So once you get to this point, then we can ask our periodic table what goes in front of mole and what goes in front of atom. We can plug those numbers in and calculate. Awesome. Okay. Real quick, some ionic and covalent formula rules. I went through and I labeled them as ionic or covalent because they get different naming rules. Okay. I've got these ones for you to check. I want you to do these ones. But ionics are always 4-step formulas. So the first step is symbols. Lead is Pb. Sulfide is sulfur. So that's step 1, symbols. Step 2 is charges. This lead is 4. So it tells me lead making a 4 charge. And sulfur